Hello, and welcome back to Sleep Science Time. I am so glad you have chosen to join me here. Wherever you are, allow yourself to settle in, letting go of the day and finding a posture of complete and total comfort. Let your shoulders soften, your jaw relax, and bring your attention to the gentle, steady rhythm of your breath, rising and falling in its own natural time. There is nothing to do right now, and nowhere else you need to be. This is a space for your mind to gently wander, to drift through the quiet wonders of our universe as you ease your way toward a deep and peaceful rest. Tonight, our journey takes us not to the distant edges of the cosmos, but to our closest celestial neighbor. It is a world that has captivated us for millennia, a ruddy pinprick of light in our night sky that has inspired stories of gods, of empires, and of strange alien life. It is a world that, in many ways, is a faded mirror of our own. Tonight, we are going to Mars. For as long as we have looked to the stars, Mars has held a special place in our collective imagination. Its distinctive red color, a hue reminiscent of rust and old iron, made it stand out. The ancient Romans named it for their god of war. But as our view grew sharper, from the first telescopes to the robotic eyes we have sent in our place, our perception of Mars began to change. We saw not a god of war, but a world of quiet, desolate beauty. We saw vast canyons that would dwarf our own Grand Canyon, and towering volcanoes that make Mount Everest look like a gentle foothill. We saw polar ice caps just like our own, that grow and shrink with the passing of the seasons. And most tantalizingly of all, we saw the unmistakable branching patterns of ancient, dried-up riverbeds, deltas, and vast ocean basins. These features told an incredible story, that this cold, desert world was not always this way. Billions of years ago, Mars was a warmer, wetter place, a world with a thick atmosphere, with blue skies, with clouds, and with liquid water flowing freely across its surface. It was a world that had all the necessary ingredients for life as we know it. This raises the most profound question we can ask of our neighbor. Did life ever begin on Mars? And if it did, could some small, hardy remnant of that life still be there waiting to be found? For decades, this question has driven our exploration. We have sent rovers to crawl across its dusty plains, to drill into its ancient rocks, and to search for any clue, any hint that we are not alone in our solar system. And just recently, within the last few weeks, the Perseverance rover, exploring an ancient river delta, has found something, a potential biosignature, a tantalizing pattern in the rocks that, here on Earth, is often created by life. It is the most significant clue we have ever found in our long search. And later in our journey tonight, we will explore exactly what the rover discovered and what it might mean. But first, to truly understand the significance of this clue, we must first understand the world it came from. We must journey back in time to the Mars that was, and explore the story of how this vibrant, watery world became the quiet, frozen desert we see today. To understand the Mars of today, we must first travel deep into its past. Let your mind drift back, not hundreds or thousands of years, but billions. We are going back to a time when our own Earth was still young, a time when the solar system was a very different place. The Mars of this ancient era was not the red desert we know. It was a blue world. The evidence for this lost world is carved into the very surface of the planet. When our robotic explorers send back images from orbit, they show us landscapes that are hauntingly familiar. We see the graceful, meandering curves of what were once great rivers. We see vast, smooth basins that were once home to deep, still oceans. And where some of these ancient rivers met the oceans, we see the unmistakable fan-shaped patterns of deltas built up over millennia by silt and sediment, just like the deltas of the Nile or the Mississippi here on Earth. The very place where the Perseverance rover is now exploring, Jezero Crater, was once a vast lake, fed by a network of rivers that breached the crater wall. We can still see the channels they carved. We can analyze the minerals they left behind. The evidence is overwhelming. Liquid water once flowed in abundance on the Martian surface. For this to be possible, the Mars of the past must have been a far more hospitable place. It would have needed a much thicker atmosphere than the thin, wispy one it has today. A thicker atmosphere would have trapped the sun's heat, creating a greenhouse effect that kept the planet warm enough for water to remain liquid, instead of instantly freezing or boiling away into space. Imagine that ancient Martian sky. It may have been a pale butterscotch color, filled with clouds of water vapor, drifting over a landscape of dark, volcanic rock and deep blue oceans. It would have been a dynamic, living world in a geological sense. A world with weather, with rain, and with the gentle, persistent sound of flowing water. It was a world that had, for a time, all of the essential ingredients for life. So, what happened? Where did this blue world go? The story of its loss is a planetary tragedy that unfolded over hundreds of millions of years. The key to it all lies deep in the planet's core. Like Earth, the young Mars had a hot, molten iron core. The churning of this liquid metal generated a powerful magnetic field, a protective, invisible shield that surrounded the planet. This magnetosphere deflected the solar wind, a constant stream of charged particles flowing from our sun. But Mars is smaller than Earth, and because of its size, its core cooled down and solidified much more quickly. As the core stopped churning, the magnetic field vanished. Mars lost its shield. Without this protection, the solar wind slammed directly into the Martian atmosphere. Over millions of years, this relentless cosmic wind stripped the atmosphere away, particle by particle, blowing it out into space. As the atmosphere thinned, the pressure dropped, and the greenhouse effect failed. The planet began to grow cold. The water that had once flowed freely could no longer exist as a liquid on the surface. Some of it was lost to space along with the atmosphere. The rest retreated, freezing into the vast polar ice caps we see today, or seeping deep underground, where it may still exist as permafrost, or perhaps even pockets of liquid brine. The blue world vanished, leaving behind a frozen, silent ghost of what it once was. A planet preserved under a thin, cold atmosphere. And it is within the layers of that frozen history that we are now searching for the fossilized clues of life that might have begun during that long-lost spring. Let your mind drift forward again, through billions of years of cosmic silence, to the present day. The warm, wet Mars is a distant memory, a ghost world preserved in an ancient rock. The Mars that greets us now is a world of stark and quiet beauty, a planet of extremes. The first thing you would notice on modern Mars is the sky. It is not the deep blue of Earth, but a thin, pale, pinkish tan. The atmosphere that was once thick enough to support oceans is now less than 1% the density of our own. It is made almost entirely of carbon dioxide, and it is incredibly cold. The average temperature on Mars hovers around -62 degrees Celsius or -80 degrees Fahrenheit. It is a world in a deep, permanent freeze. The landscape is breathtaking in its scale. Mars is home to the largest volcano in the entire solar system, Olympus Mons. It is a colossal shield volcano, so wide that its base would cover the entire state of Arizona, and so tall that it rises 3 times higher than Mount Everest, its peak poking out above the thin Martian atmosphere. It has been dormant for millions of years, a silent giant on the planet's surface. Stretching across the Martian equator is another feature of unimaginable size, Valles Marineris. This is not just a canyon, it is a system of canyons that stretches for over 4,000 kilometers or 2,500 miles. If it were on Earth, it would span the entire width of the United States. In places, it is over 7 kilometers or 4 miles deep. It is a vast, gaping wound in the planet's crust, likely formed billions of years ago as the planet cooled and stretched. And of course, there is the famous red dust. The entire surface of Mars is covered in a fine, powdery layer of iron oxide, what we would simply call rust. This iron-rich dust is what gives the planet its distinctive color. It is whipped up by winds that can sometimes grow into planet-encircling dust storms, shrouding the entire world in a red haze for weeks at a time. Thanks to the microphones on the Perseverance rover, we even know what these winds sound like: a low, quiet hum, the sound of an ancient world whispering to itself. But not all the water is gone. At the poles, Mars has brilliant white ice caps, much like Earth's. They are a mixture of frozen water and frozen carbon dioxide, or dry ice. With the changing of the seasons, the carbon dioxide ice sublimates back into the atmosphere in the summer and freezes back onto the surface in the winter, causing the caps to visibly grow and shrink. And deep beneath the surface, scientists believe there are still vast reservoirs of water ice, a frozen legacy of Mars's ancient blue past. This is the world we are exploring today. It is a world of silent volcanoes, of colossal canyons, and of a thin, cold air that hums with the whisper of the wind. It is a desert planet, but it is not a dead one. It is a dynamic world, shaped by wind, by ice, and by the faint echoes of a much more vibrant past. And it is in this cold, red desert that we continue our search for the answer to that profound question: did life ever find a way? For centuries, Mars was just a point of light in our sky, a world known only through the lenses of telescopes. But in the latter half of the 20th century, we began to reach out. We sent orbiters to map its surface and landers to touch its rusty soil. And most remarkably, we sent rovers, robotic geologists on wheels, to become our eyes, hands, and feet on this alien world. The story of the rovers is a story of incredible ingenuity and persistence. The very first successful rover was a tiny, microwave-sized vehicle named Sojourner, which landed in 1997. It was a humble beginning, but it proved that we could drive a robot on the surface of another planet, a monumental achievement. Then, in 2004, came the twin rovers, Spirit and Opportunity. These were true explorers. They were designed to last for just 90 Martian days, but they defied all expectations. Spirit roamed the landscape for over 6 years, while Opportunity continued its journey for an astonishing 15 years, sending back invaluable data about Mars's watery past. They were our first true field geologists on the Red Planet, confirming that vast regions of Mars were once soaked in water. These early missions paved the way for the next generation of explorers. In 2012, the car-sized rover Curiosity landed in Jezero Crater. Curiosity is a mobile science laboratory of incredible power. It carries a suite of advanced instruments designed to analyze the chemistry of Martian rocks and soil in unprecedented detail. It was Curiosity that found definitive evidence of an ancient freshwater lake at its landing site, a place that would have been a habitable environment for microbial life billions of years ago. It even detected complex organic molecules, the chemical building blocks of life, preserved in ancient mudstone. And that brings us to the most advanced rover ever sent to another world, the one whose story we are following tonight, Perseverance. Landing in 2021, Perseverance had a very specific mission: to seek the signs of ancient life. It was sent to Jezero Crater for one reason: because billions of years ago, it was a deep, calm lake, fed by a river that built a beautiful delta. On Earth, river deltas are fantastic at preserving the chemical traces of life. The hope was that the same would be true on Mars. Perseverance is not just looking, it is collecting. It is equipped with a complex drilling system that allows it to take small core samples of the most interesting rocks it finds. It then seals these samples in pristine metal tubes and leaves them in caches on the surface. These are a message in a bottle for a future mission, a planned collaboration between NASA and the European Space Agency to one day collect these samples and return them to Earth, where our most powerful laboratories can analyze them for the definitive signs of past life. These rovers are more than just machines. They are our proxies, our pioneers, crawling across a silent, frozen desert, piecing together the story of a lost blue world. And it is Perseverance, in the heart of that ancient lakebed, that has found the most compelling clue to date. A clue that brings us closer than ever to answering that age-old question. Let your mind settle now. In the quiet, dusty landscape of Jezero Crater, beside the Perseverance rover, it is here, in the heart of an ancient, dried-up lake, that our story takes a remarkable turn. The rover has been meticulously examining the rocks of a former river delta, a place where, billions of years ago, water would have deposited sediments and perhaps the traces of life. Recently, the rover turned its attention to a specific rock formation named Jezero Falls. Using a drill at the end of its robotic arm, it extracted a small core sample, no bigger than a piece of chalk, from a target rock. The name given to this precious sample is Sapphire Canyon, and what the rover's onboard laboratory instruments found within this tiny piece of Mars has sent a wave of quiet excitement through the scientific community back on Earth. The first thing the instruments detected was a rich chemistry. The sample contained organic carbon, the fundamental element for all known life, along with sulfur, phosphorus, and oxidized iron. This combination of elements, in a watery environment, could have served as a potent energy source for ancient microbial life. It's like finding a pantry stocked with all the right ingredients, but this alone is not a sign of life. The most tantalizing clue came from the way the minerals were arranged. The instruments detected a distinctive pattern of iron-rich minerals, specifically vivianite and greigite, clustered together in what the science team described as leopard spots. Now, this is where the discovery becomes truly compelling. Here on Earth, this exact combination and pattern of minerals is often associated with microbial processes. Certain types of terrestrial microbes can produce greigite, and the mineral vivianite is frequently found in the sediments of lakes, where organic matter, like dead algae, has decayed. While there are ways for these minerals to form without the presence of life, the specific geological conditions at Jezero Falls make those non-biological explanations less likely. Furthermore, this discovery was made in some of the youngest sedimentary rocks the rover has investigated. This suggests that the period when Mars was potentially habitable may have lasted for much longer than we once thought. The window of opportunity for life to begin and take hold may have been wider than we ever imagined. It is essential, of course, to approach this with the calm and careful patience of science. This is not yet proof of Martian life. It is what scientists call a potential biosignature. It is a pattern in the rock that is highly suggestive of life, but for which all other possibilities must first be ruled out. The data from Perseverance has been shared with scientists all around the world who are now studying it, debating it, and trying to understand its true origin. The final answer may have to wait until these precious samples, including the one from Sapphire Canyon, are brought back to Earth by a future mission. Only then, with the full power of our planet's most advanced laboratories, can we be certain. But for now, we have the most significant clue ever found in our centuries-long search. A quiet, mineral-laced pattern in a small piece of rock that tells of a time when the waters of Mars may have been alive. The clue in Sapphire Canyon is a profound and specific discovery, but it is part of a much larger, more patient search. When scientists look for life on Mars, they are not necessarily looking for living creatures. They are primarily searching for something more fundamental, habitable environments. These are places, either in the present or in the distant past, that possessed all the necessary ingredients for life as we know it. So, what are those ingredients? For life to arise, it seems to require at least 3 key things. First, it needs a liquid solvent, a medium in which the chemistry of life can happen. On Earth, that solvent is liquid water. Second, it needs a source of energy. This could be energy from the sun, or it could be chemical energy from the reactions between rocks and water. And third, it needs access to the right raw materials, specifically organic compounds rich in elements like carbon, hydrogen, nitrogen, and phosphorus. We know from the evidence we've discussed that ancient Mars had all 3 of these ingredients in abundance. Its surface was warm, wet, and chemically rich. But what about the Mars of today? The surface is a harsh environment, bombarded by radiation and far too cold for pure liquid water. So, if life does still exist on Mars, where might it be hiding? The most promising answer is underground. Deep beneath the Martian surface, any potential life would be shielded from the harmful radiation that scours the planet. And while the surface is frozen, the interior of the planet is still warmer due to residual heat from its formation. It is possible that deep underground, this geothermal heat could melt the subsurface ice, creating pockets of liquid water, or at least very salty brines which remain liquid at much lower temperatures. These underground aquifers, or wet rock layers, would be potential oases, dark and isolated, but possibly full of the chemical energy needed to sustain a simple microbial ecosystem. Life on Earth exists in similar dark, deep environments, from microbes in volcanic vents at the bottom of our oceans to bacteria living miles deep in the Earth's crust. It is not unreasonable to think that if life on Mars survived the great climate shift, it would have retreated to these last hidden refuges. Another intriguing possibility is the existence of lava tubes. When ancient Martian volcanoes were still active, they would have created vast underground tunnels. As rivers of lava cooled and drained away, these caves and tunnels, some of which could be enormous, would provide a stable and protected environment. They would have near constant temperatures and would be completely shielded from surface radiation, making them another prime location to search for signs of present-day life. For now, these pockets of possibility remain beyond the reach of our rovers, which are designed to explore the surface. But every piece of data they collect about the planet's geology and history helps us understand where these hidden habitats might be, and guides the design of future missions that might one day drill deep beneath the rusty soil, searching for the quiet, hidden heart of a living Mars. Let your mind drift now on a gentle current of possibility. We have asked if life could exist on Mars, but it is just as fascinating to wonder what form that life might take. When we think of aliens, our imaginations often conjure images from science fiction, complex creatures, intelligent beings. But the life that scientists are searching for on Mars is something far more fundamental, and in its own way, far more profound. If life ever began on Mars, and if it still survives today, it is almost certainly microbial. We are searching for the equivalent of bacteria or archaea, simple, single-celled organisms, too small to be seen with the naked eye. Life on our own planet was exclusively microbial for billions of years before the first complex organisms ever appeared. So, if we find life on Mars, it will likely be from this first, most resilient stage of life's journey. To imagine what Martian microbes might be like, we don't have to look to science fiction. We can look right here, on Earth. Our own planet is home to a remarkable category of life called extremophiles. These are organisms that don't just survive, but thrive in environments that we would consider completely uninhabitable. There are microbes that live in the boiling, acidic water of hot springs. There are bacteria that flourish in the crushing pressure and total darkness of the deepest ocean trenches, drawing their energy not from the sun, but from the chemical reactions of volcanic vents. There are organisms that live inside solid rock, miles beneath the Earth's surface, and others that can survive being completely dehydrated for years in the driest deserts on the planet, like the Atacama in South America, a place often used as a stand-in for the Martian landscape. Some of these extremophiles can even withstand incredible doses of radiation, far more than any human could survive. They have evolved remarkable mechanisms to repair their own DNA, allowing them to endure in the most hostile conditions. These incredible organisms show us that life is far more tenacious and adaptable than we ever thought possible. They prove that life doesn't require a gentle, garden-like world to take hold. It can find a way in the dark, in the cold, under immense pressure, and with very little water. And so, when we search for life on Mars, we are searching for its extremophiles. We are looking for microbes that may have adapted to the thin atmosphere and cold temperatures. Perhaps they live in salty, underground brines that keep them from freezing. Perhaps they draw their energy from the chemical reactions between water and rock, deep beneath the surface, completely independent of sunlight. Or perhaps they lie dormant in the frozen soil, waiting for the rare, fleeting moments when a tiny bit of ice melts, giving them a brief chance to live before freezing once more. The life we are looking for on Mars would not be exotic in its complexity, but in its sheer resilience. It would be a quiet, simple, and incredibly tough form of life, a testament to the enduring power of biology to find a foothold, even on a world that has long since lost its gentle past. For as long as we have known that Mars is a world, and not just a point of light, we have dreamt of going there. It is a deep and persistent dream, the idea that humanity might one day walk upon the surface of another planet, to see a Martian sunrise, and to make a second home for ourselves in the solar system. This is a quiet, patient dream, for the challenges of sending humans to Mars are immense, far greater than any journey we have ever undertaken before. First, there is the journey itself. A trip to Mars would take many months, spent in the deep, empty space between worlds. Astronauts would have to be protected from the constant exposure to cosmic radiation, far from the safety of Earth's magnetic field. And upon arrival, they would find an environment far more hostile than any on Earth. The atmosphere is unbreathable, the temperatures are lethally cold, and the surface is bathed in the same radiation that makes the journey so hazardous. There is no room for error. Any human presence on Mars would have to exist within a completely self-contained habitat, a small sealed bubble of Earth brought to a new world. Life on Mars would mean relying entirely on technology for survival. Astronauts would need to generate their own power, likely from solar panels stretching across the rusty soil. They would need to grow their own food in subterranean greenhouses, and most critically, they would need to make their own breathable air. The Perseverance rover is already testing this very idea with an instrument called MOXIE, which has successfully generated small amounts of oxygen from the thin, carbon dioxide-rich Martian atmosphere. It is a small but crucial first step. So why do we dream this difficult dream? Why do we feel this pull to a world so inhospitable? Part of the answer is the pursuit of knowledge, the chance to conduct scientific research that is impossible to do with robots alone. Geologists could explore vast canyons, and biologists could search for life in ways that a rover never could. There is also the powerful idea of ensuring the long-term survival of our species. Having a self-sufficient outpost on another world would be an insurance policy for humanity, a safeguard against any catastrophe that might one day befall our home planet. But perhaps the deepest reason is simply the innate spirit of exploration that has defined humanity for millennia. It is the same spirit that led our ancestors to cross oceans, and explore new continents. It is a quiet, persistent drive to see what lies over the next hill, or in this case, the next world. The dream of Mars is not a dream of conquest, but of curiosity. It is a testament to life's own gentle impulse to reach out, to learn, and to expand its presence in a vast and silent universe. Let your mind drift now, away from the rusty surface of Mars, back through the darkness of space, until both Mars and our own Earth are just small points of light. From this immense distance, we gain a new sense of perspective. Many years ago, the Voyager 1 spacecraft looked back and took a famous photograph of our world. A single tiny pixel suspended in a sunbeam. It was called the pale blue dot. That image reminded us that our world is a small, fragile stage in a vast cosmic arena. Every person you've ever known, every joy you've ever felt, has happened right here on that tiny suspended dot. Now, think of Mars. It is the pale red dot. Another small world, not so different from our own. A world that for a time may have also harbored the miracle of life. But it is a world where something went wrong. A world that lost its protective atmosphere, lost its flowing water, and lost its warmth. It serves as a quiet, sobering lesson, written across an entire planet, of just how fragile a habitable world can be. Our search for life on Mars, then, is not just about finding aliens. It is also a search for a deeper understanding of our own home. By studying how Mars changed, we learn more about the delicate balance of geology, atmosphere, and water that allows life on Earth to flourish. We learn about the planetary processes that create a haven for life and the ones that can erase it. The silence of Mars speaks volumes. It tells us that a warm, wet, living world is not a guarantee. It is a precious and perhaps rare gift. The rusty dust of the red planet teaches us to look back at the vibrant blues and greens of our own world with a renewed sense of wonder and appreciation. The search for a single microbe on another world is, in the end, a profound act of self-reflection. It is an expression of life's desire to understand itself, to know its own origins, and to appreciate the incredible, delicate miracle of its own existence. Mars is not just a destination for our rockets and our rovers. It is a mirror reflecting the preciousness of the world we call home. And so, our journey to the red planet comes to a quiet end. We have drifted through billions of years of history, from a lost world of blue oceans to the silent red desert of today. We have followed the faint tracks of our robotic explorers across its dusty plains, and we have shared in the patient, distant dream of one day seeing a human footprint left in its soil. Mars is a world of profound silence, a world of patient waiting. It waits for the light of a distant sun to warm its surface. It waits for the return of a future mission to unlock the secrets held in its rocks. And it reminds us of the beauty of patience, of the slow and gentle unfolding of cosmic time. As you now prepare to drift into your own quiet world of sleep, you can carry this feeling of peaceful immensity with you. Let the image of that silent red world be a comforting one. It is a reminder that even in the most desolate of places, there is a story to be told, a history to be uncovered, and a profound beauty to be found. The universe will continue its slow, silent motion while you rest. The stars will continue to shine, and Mars will continue its lonely orbit, holding its secrets for another day. And you too can now let go and allow yourself to drift into the peaceful silence of your own dreams. Thank you for joining me on this journey to Mars. If you found this time relaxing, a gentle like or a quiet subscription is always deeply appreciated. If you'd like me to discuss any science topics, please leave them in the comments below. Until next time, I hope your rest is deep and your dreams are filled with wonder. Good night and take care.